Okay, another lesson on factoring. In all honesty, today's lesson, you really could do so much of it with previous knowledge. There is one special, particular new thing that we have to talk about. It's highlighted up here in the box. A squared minus b squared. Immediately you can see we only have two terms on this left-hand side as opposed to having three. A difference of squares. This will factor very, very specially into the quantity a plus b times a minus b. These two terms here are what we will call conjugates. And this will become more important as we progress later on. We're going to see that conjugates will be something that we'll be talking about even in our lessons next week. Conjugates look exactly the same. You have an a and a b with one huge difference. You have an addition of terms in the one and then a subtraction in the other. So when you see that, you could say that these are conjugates. And we'll get more and more into this next week. But let's immediately jump into number one. 9x squared minus 4, you only see two terms. It seems to be fitting this pattern. It is, in fact. The very first question we must ask, though, is there a greatest common factor, a number that divides into 9 and 4 other than 1? And actually there is not. So what we do instead is we try immediately to do the factoring that we see up above in the box. Now the fact that we have conjugates mean that we'd see the same expression, pretty much just one is an addition and the other is a subtraction. So how might we multiply to a 9x squared? Well, try a 3x and a 3x. Again, you have to have the same numbers in both parentheses. 3 times 3 is 9. Sometimes kids will say, well, can you just think of that as taking a square root of 9 and getting a 3, and then you'd know that that would be the number in both parentheses? You can certainly do that. Similarly, the square root of 4 is 2, so you'd have to have a 2 here and a 2 over here. One term would have a plus, the other would have a minus. One thing I do want to talk about, just reinforcing what we've talked about in the past, drawing that nose and mouth, you'd have a 6x and then a minus 6x. You'd notice that that adds up to a 0. And that's exactly what we should get. There is no middle term in that expression. This is exactly what must take place. Similarly, 2 times negative 2 is negative 4. So we know that this is the way we must factor. Taking a look at number 2, before you start breaking down to two parentheses, the ongoing question is always the same. Is there a common factor, a number that divides into the 16 and the 36? Very often kids might say, well, yes, a 2. And that is true that 2 divides into 16 and 36, but we're always looking for the greatest common factor. Is there a number larger than 2 that divides into 16 and divides into 36? Well, we could quickly see that 4 is the largest. Obviously, a 2, a 4, an 8, and a 16 divide into 16 itself, but only the 4 would also divide into the 36. So divide out a 4. That's what factoring really is doing. It's undistributing or dividing. And what are we left with? Well, then a 4y squared, 36 divided by 4 is a 9. And sure enough, now that we look inside these parentheses, you can see that we have a difference of squares that we can now factor down. And so keep your 4 out in front. But now we're going to look for those conjugates. What number times itself is 4? Well, a 2. And we'll have to have a 2y. What number multiplied to itself is 9? Well, a 3, and we'll need 3's in both. But we'll need x squared for both of these, because x squared times x squared is x to the 4th. One term will have a plus, the other would have a minus. And this is our factored form in its entirety. Now, as we look on, you can see that the other two remaining items in the box are going to have the same terms of a plus b or a minus b being duplicated. Today's factoring is a little bit more special, and that's in repeated factors in that regard. So let's take a look at number 3, just very, very fast. First question, is there a greatest common factor that I could divide out of a 4, a 12, and a 9? There is not. So instead, what we can do immediately is check and see if we have a way to multiply to a 4x squared. It's very smart to try 2x and 2x. And the reason why you'd like to do that, of course, is we're seeing that there are times when these factors wind up getting repeated. We, of course, have to multiply to a 9, as we can see right here, and we'd like to add to a negative 12. You might wonder how we might multiply to a 9. Why not try a 3 and a 3? That's a great first check. Drawing in a nose and a mouth, we'd get a 6x and a 6x. 6 and 6 could add up to negative 12 if they're both negative. And that's exactly what we want to have happen. You can see negative 6x and negative 6x adds up to negative 12, but negative 3 times negative 3 actually will multiply to a positive 9. Look at these two expressions, very different. We never saw this happen in our homework before. These factors are the same. And because they're the same, we can write it more simply as 2x minus 3 quantity squared. Likewise, we come over here to number 4. And there is no common factor to divide out. We're looking to multiply to 25. We're thinking about adding up to a 10. And, just getting started here very, very fast. Of course, we'll have an x and an x. Multiplying to 25, why not try 5 and 5, especially because we know that these factors very well could repeat. Look at the nose and the mouth. 5x and 5x could add up to a 10x. So make both of these a plus. Then you multiply a 5 and a 5 to a 25. You'll add up to a 10x. Everything is the way it should be. We can write this more simply as x plus 5 quantity squared. As we move on, let's take a look at number 5. Please always, always, always ask yourself, is there a greatest common factor? Is there a number I could divide out from all three of these? There is. You very well could divide out a 5. And as you do that, you can see that you would be left with a x squared plus 2x plus 1. Now from here, we know that we'd have to multiply to a 1, and we'd have to add to a 2. And you might realize there aren't too many ways you're going to multiply to a 1. You might just try a 1 and a 1 itself. Look at that, nose, mouth, 1x and 1x add up to a 2x, and make them both positive, of course. 1 times 1 is 1 itself. Final answer, you could write 5 times x plus 1 quantity squared. But you see the importance of checking if there's a greatest common factor. Let's take a look at number 6. 12x squared minus 36x plus 27. And it might take you a while to see that the greatest common factor will actually be a 3. If I were to divide out a 3, I would have 4x squared minus 12x plus 9. And from here, of course, as we factor this out, we know that we're going to have to multiply to a 9 and add up to a 12. So why not just try the 2x and the 2x? Because we're seeing so many problems where these numbers are the same. How might we multiply to 9? Well, let's try a 3 and a 3. Drawing that nose and mouth, you'd have a 6x and a 6x. And I said add up to a 12. I meant to say add up to a negative 12. My apologies. You would need to have a negative 6 and a negative 6 to add to that negative 12. Make both of these terms a minus 3 so that you'd get negative 6 and negative 6 adding to negative 12. Don't forget to check your multiplication. Negative 3 times negative 3 is a 9. From here, we'll be left with 3 times 2x minus 3 quantity squared. So much of today's work is actually very similar to what we were doing before. Let's real quickly take a look at number 7. Solving. Tell you what, get 0 on one side, so add a 9 to both sides. You'll have x squared minus 6x plus 9 equals 0. Always, always, always get 0 on one side. Factoring. Well, my goodness, if you factor this out, hopefully you can see that you'd have to multiply to a 9. You'd have to add to a negative 6. You might guess that we'll try a 3 and a 3. And nose mouth, you'd get 3x and 3x. Could we get that to add up to a negative 6? You bet. If the 3's were both negative, don't forget to check, hey, do I really multiply to a 9? I do. Now here's the neat thing. Technically, x minus 3 would equal 0, x minus 3 would equal 0. Add a 3 to both sides, and you just have x equals 3. If you added a 3 over here, you get the same answer. Really, we're just being redundant. We're saying that x equals 3. You could just write it down once. For number 8, tell you what, let's minus a 12 from both sides. Again, let's get our 0 on one side. And from here we go again with that very first type of factoring of the day. This is a difference of squares. Try a 4. We'd need to have a plus and a minus. Double check your nose mouth. 4a and a negative 4a would add up to a 0a, which is exactly what you'd like to see. A plus 4 would equal 0. A minus 4 would equal 0. Well, solving, you'd get a equals negative 4. Right here, you'd get a equals positive 4. So two different answers here. All right, and the last one of the day. The safe working load in pounds for a rope can be found using this function. S equals 450 c squared, where c is the circumference in inches of the rope. Find the diameter of the rope needed to lift an object that weighs 4,050 pounds. Well, let's see if we could real quickly work this out. You can see that if we have a safety lifting an object of 4,050, that would be the amount of weight, the safe working load in pounds. We can put this over here. Very quickly we can finish this up by dividing. Well, as we want to solve here, we could divide both sides by 4,500, or 450, so sorry. C squared, of course, would equal 9. Now, the circumference has to be a positive value. You could, if you'd like, subtract a 9 from both sides and get 0 equals c squared minus 9. And we could factor that into c plus 3, c minus 3, and set both of these equal to 0. Well, you'd know that your circumference can't be negative. We'd have to throw out this value of negative 3. That wouldn't make any sense. So the circumference would be a 3, but they're not asking for the circumference, they're asking for the diameter. The circumference from geometry was pi times the diameter. So if your circumference is 3, your diameter, plain and simply, is just going to be dividing both sides by pi. And all you have to do real quickly is just type in 3 divided by, and use the pi button on your calculator, and then you can finish that up. So 3 divided by pi, evidently you'd get about 0.955, something like that. So 0.955 inches. So that would be your diameter. Okay, so hopefully that's making sense for you. A lot of work that we've already done before. The new stuff is really this difference of squares. Keep working on it. Hopefully it's getting better for you.